Hello, everybody. Welcome to the Spirit of Apollo. I'm your host, Mark Lesmeister. Today, we're going to put another section onto the rocket. I'm going to do a little bit differently today. I'm going to actually build the rocket first, and then we will talk about what it means, because today's project involves the engines. Before I do that, though, I'd like to take a moment to acknowledge the passing of President George H.W. Bush, who passed away yesterday. A lot of people don't know this, but it was actually President Bush who set our national policy space goals specifically on the exploration of Mars and returning to the moon. Before President Bush's initiative, called the Space Exploration Initiative, the planning by NASA was somewhat nebulous. And so just want to say a farewell, President Bush. You'll be missed. And so with that said, I will proceed with bag 6, and we'll show you the results after it's done. Okay, so bag 6 completed stage 1 of the rocket, and now we're starting to get a really good appreciation for how big this rocket's going to be. That's only appropriate because the Saturn V rocket really was the most gargantuan rocket that was ever built. It was the largest thing to ever fly. It weighed in at over 6,540,000 pounds fully loaded, and it was 360 feet tall. The Saturn V also holds the record for the most powerful rocket ever built. In fact, it could launch over 140,000 kilograms to low Earth orbit. That's larger than even the Space Launch System rockets that NASA is developing right now. As it stands right now, the SLS Block II rockets will be able to carry about 130,000 kilograms into low Earth orbit. Now, one of the reasons for all that power in the Saturn V was these bad boys right here. These are the F1 engines. The F1 engine was basically the rocket engine. It was the rocket engine that Harrods would sell if Harrods sold rocket engines. The F1 rocket engine was the most powerful single nozzle rocket engine ever produced. It burned a combination of kerosene and liquid oxygen, and it could produce 6.9 meganewtons of thrust. That's 1,550,000 pounds of thrust for those of you who are not using metric system. Here's a picture from the Marshall Space Flight Center showing work being done on the F1 engines. It really gives you a sense of the scale of these engines. The Saturn V used 5 F1 engines. The outer 4 could be steered or gimbaled, as they call it. Here's a test firing of all 5 F1 engines at one time, also at the Marshall Space Flight Center. And these 5 engines had the job of getting the rocket up to 36 miles of altitude and going about 6,000 miles per hour. The F1 engine is considered so important to the history of spaceflight that Jeff Bezos, the founder of Amazon and the owner of his own rocket company, Blue Origin, funded a private effort to recover some F1 engines from the Apollo 12 launch. I hope that when we return to the moon or when we land on Mars, that the people responsible for those giant steps will take a moment to appreciate the efforts of those that came before them, perhaps to acknowledge the inventors of the F1 engine, and perhaps even to appreciate the contributions of a former naval aviator who helped us understand that exploring the solar system was going to be the work of generations. Until next time, Godspeed.